Okay. So again, so the circumcenter is equidistant from all three vertices. Now this is not, mine is not drawn to scale, so it's not perfect, but in theory, these three vertices or these three line segments would be congruent, okay? So PA is congruent to PB, is congruent to PC. So just making it a little bit simpler than the diagram that they showed you. Does this help? Yes? A little bit better? Okay. Okay, so this is the circumcenter theorem. Does anyone still need a couple seconds to write it down? No? Okay. All right. So we can solve problems using this theorem. Just like any theorem that we have, it allows us to solve different types of problems. So can I have a volunteer read? And I know Tyrone reads a lot. You'll be able to read again, but for now I would like someone other than Tyrone to get a chance. Who would like to go first? Who would like to read this situation? Come on, guys, somebody read. Let's go. Let's not be shy. Somebody read in 3, 2, and 1.
Can I do it?
Go ahead, Jalen.
Line KZ, line LZ, and line MZ are perpendicular bisectors of triangle GHJ. Use the given information to find the length of each segment. Note that the figure is not drawn to scale. Do I read the given part too?
Yes, please.
Given ZM equals 7, ZJ equals 25, HK equals 20. Find ZH and HG.
Awesome. All right. So I'm going to highlight everything that is given here. So ZM equals 7. So let me highlight that. ZM, that's 7. ZJ is 25. ZJ is 25. And HK is 20. HK, right here, that one is 20. Okay. Find ZH and HG. ZH and HG. So ZH is right here, and HG is this whole thing over here. Okay, lots of information, right? Lots of information, and we kind of have to put it all together given what we know. So again, what do we know? What do we know using the circumcenter theorem? You guys just wrote this down, so look back in your notes. What does the circumcenter theorem tell me?
Z is the circumcenter.
So if Z, okay, good. So Z is the circumcenter. So what has to be true?
That the bisectors of the sides are also equidistant.
Good, nice job. So it's equidistant. So let me go back really quickly. The perpendicular bisectors of the sides of the triangle that intersect at a point that is equidistant from the vertices of the triangle. There's kind of a lot going on, okay? The perpendicular bisectors of the sides of a triangle intersect at a point that is equidistant from the vertices. So here, which lines would be equidistant? If it has to be equidistant from the vertices.
Bella's computer's broke.
Perla, what?
Bella's computer's like messed up.
That's okay. You can try. You can either try speaking Perla, and maybe Tyrone's mic will pick it up, or you can type it in the chat.
What was the question?
So again, if the circumcenter is equidistant from the vertices, keyword vertices, then
Mhm.
what 3 places is this circumcenter equidistant from? So what is equal?
J.
Mhm.
Wait. J, H, and G.
Right. So the 3 equidistant line segments would be ZJ. What else?
Z, G,
ZG
Z, A.
and ZH, exactly.
Could there also be another set?
That's the only ones, according to the circumcenter theorem, that is the only thing we know for sure.
Oh, okay.
Okay. So if ZJ, we already know that that's 25, how much is ZH going to be?
ZH?
Mhm.
I want to say 90, but I don't think it's 90.
ZH is a line segment, not an angle, a line segment. Good, Perla. I already know that these 3 line segments are equidistant. So if one of them is 25,
All of them are 25.
all of them have to be 25. So all 3 of these are 25. Let me fix that. Okay, so I already know ZH, so I can answer that part. ZH equals 25. Now I need to figure out what is the measure of HG. Okay, let me go back again. The circumcenter is located where all the perpendicular bisectors intersect. What does a perpendicular bisector do?
It,
What does a perpendicular bisector do to a line segment? It's all in the
does it
name.
split in half?
Cuts it in half, exactly. Cuts it in half. And what else?
Makes them equal?
Cuts them in half, equal on both sides, and Perla says they will be 90-degree angles. Exactly. Perpendicular bisectors, 90-degree angles, and cuts it in half. So let's take a look here. Where do you guys see the 90-degree angles? There's a
At
few.
K, L, and M.
K, L, and M. So those are the places where you have perpendicular bisectors. So which line segment, and listen carefully, which line segment is K cutting in half?
Carla said.
GH, exactly. K is the midpoint of GH. So if KH is 20, how much is GH going to be?
20.
Also 20, yeah. Because K is right in the middle. So now we can answer this question. HJ, or HG, I mean, equals how much?
20.
HG.
Oh.
Good, Jalen, 40. Okay, because again, K is the perpendicular bisector. That point, K is the midpoint. Same thing goes for L, right? L would be the midpoint of HJ And M would be the midpoint of GJ. But that's not what they were asking for, obviously.
Oh, I see it now.
Okay. Now, let me see if this has what I'm asking. Hold on. Yeah. Okay, this one's very similar. So I want you guys to read it carefully. I'll start labeling. Who would like to read this one? Tyrone, go ahead.
KZZ, LZ, and MZ are the perpendicular bisectors of triangle GHJ. Use the given information to find the length of each segment. Note that the figure is not drawn to scale.
All right. Go ahead and read our given, and I'll start highlighting.
ZG equals 65. HL equals 63. And ZL equals 16. And we have to find HJ and ZJ.
Awesome. Okay. CL, here it is, 16. Okay. HJ and ZJ.
And Z is the circumcenter.
And Z is the circumcenter, exactly. All right, so start thinking about it. Start doing what you need to do. See if you can give me the answers in the chat. I'll give you guys about 2 minutes. Okay, Jalen, I already got it. 126 and 65. So which one is 126? HJ. Good. How'd you get that?
Wait, H.
How'd you get 126? $63 plus 63. Yeah, this is HJ is this whole thing. We know that that's the midpoint. So this is also 63. So the whole thing has to be 126. And then how did you get 65? Right, GZ is 65, so ZJ also has to be 65. Okay, well now I'm gonna ask a question that the textbook didn't ask, but let's see if we can think about this. What is the measure of HZ? HZ, right here. Yeah, 65 also, good. We know this because that's the other missing,
Perpendicular.
yeah. So this is also 65. Okay, here's another one that the textbook didn't ask. What about, let me see. Actually, hold on, no. I'm gonna ask a different question. Okay, but questions on this so far before I switch it up a little bit. Okay, I'm gonna go back to this problem really quickly. Yeah, because this one has a good, okay. So ignore everything from the question because I'm gonna just ask something a little bit different. The question, the textbook didn't ask this, but I wanna know GM. Take a look, think about it. How can I find GM?
Is it 32?
32, where you got 32 from?
I added 25 and 7.
Okay. Adding 25 plus 7 is not going to help us out, but you're thinking on the right track. Perla, where are you getting 25 from? Assuming they might be the same length, I am trusting my eyeballs. Those are famous last words, Perla. Famous last words. Never trust your eyeballs. And also it says the figure is not drawn to scale. So that's not going to help you out, unfortunately. $18 guessing. How are you guessing 18? Ooh, Perla has it. What is it? Don't move on. Okay. 25 minus 7. No. Perla, I will wait for you. You have 30 seconds to figure out what you're doing. Is it also 20? Okay, why do you think it might also be 20? Wild guess.
Wait.
Wait, I know.
What?
Okay, I know. Wait, let me talk.
Go, what is it?
Come over here. Thermal's computer turned off.
You turned it on.
That's because she grabbed it. Okay, because M is a perpendicular bisector of GJ because of the right angle we can see. So that must mean it's 20, I think.
Okay. You're thinking some good thoughts, but those thoughts are not 100% accurate.
Thermal is trying to tag me.
I know, I'm sorry. It is what it is.
Wait, what was it?
Okay. So far, I've heard a few good ideas, but I have not heard the correct idea.
45. I'm joking.
Definitely not 45. So I'm going to give you guys one little hint. A tiny little hint. Let me think of the little hint.
At the moment you say the hint, Pro is gonna get it.
My hint is that in order to get the right answer, you need to consult with a good friend of ours that is Greek.
Pythagorean theorem. I don't know.
Oh, Pythagorean theorem. Think about it.
HL? Wait, no. Wait, is it the Pythagorean theorem or not?
Yes.
Wait, so I had to figure out the plot, the point, or whatever? Like A, B, and C? Wait, Pro is gonna solve it, even though she cheated last time. She turned off my computer. I'm sad. She's really excited. She said don't do it.
I'm not going to do it yet. I'm just going to draw this nice little triangle here.
She's using her big brain.
And I'm going to label what I have so far.
Is A 20? Wait.
Miss,
Yeah.
according to my calculations, it's 25.96150.997.
Nope.
Oh.
Oh, wow.
See if anyone else can get it.
Okay.
Perla has left the chat.
Remember that Pythagoras is very particular about which sides are what he labels each
Is
side.
A 25, B 7, and C 90?
No. Okay. What is the Pythagorean theorem again?
A squared plus B squared. Oh, Perla says she got it.
That's fine, but you do it on your own, but I'm going to go through it. A
Equals C
squared
squared.
plus B squared equals C squared. Which one does C have to be?
The hypotenuse.
C has to be the hypotenuse. Which of these is the hypotenuse?
25.
25 is the hypotenuse. So 25 is the hypotenuse, which means the x and the 7, those go over here. So I'm going to set it up for you. I want you guys to see if you can figure it out from here. Figure out the value of x. Ooh, Perla got it. Okay.
Perla always, oh my God.
So let's go through it together. Now that Perla's got it, but Perla, you have to tell me what to, oh, you can't say it out loud.
Oh, wait.
Okay, what do I do first? How do you get 25? I mean 24.
Wait, she's gonna talk from my computer.
Okay. So the first thing I did was simplify the exponents.
Mhm.
Miss, isn't 25 squared?
Yeah, sorry.
Okay. So 7 squared is equal to 49.
Mhm.
And then 25 squared is equal to 625. And we can simplify the x squared. So
Good.
it just stays like that. So then
Okay.
I subtracted 49.
Mhm.
And I got, I don't remember what I got, wait. Minus 49. So 576.
Mhm.
And then I took the square root, and then that gave me 24.
Beautiful. That is exactly correct. Those are the perfect exact steps that we got to take to get our final answer of 24.
Technically, I got it right because it was me talking. I'm joking. Good job.
There you go. All right, we're going to do a couple more problems like this, but do I have questions so far on how we use the Pythagorean theorem? How did I know? How did you know that you could use Pythagorean theorem? What type of
Because,
triangle?
like, right triangle.
Yeah, the
Because you
only
see the
time
90 degrees.
the only time you can use the Pythagorean theorem is if you have a right triangle. So that's why we did what we did, and that's how we got our answer. Good job, Perla. Nice job. Let's do a couple more. Hold on.
Oh, I wanted to do the proof.
I know, I'm kind of skipping around. I'm gonna do this first and then the proof, okay?
Okay.
Okay. So here we go, it's very similar. Let me go ahead and label everything, and then you guys can try the actual problems.
ZD,
So,
ZE,
ZB.
and ZF are the perpendicular bisectors. Remember that.
Yes. So ZB is 145. ZD
The
is
100.
100.
And ZF is 17.
And ZF is 17. ZF. Okay. Okay. Question is, how do you find AB and AC?
Oh, also Z is the midpoint once again. Wait, not midpoint.
Z is the
Circumcenter.
Circumcenter, yeah. Okay, so let's strategize. How would I find AB and AC?
Hmm.
And I'll highlight those as well.
I'm gonna guess we're gonna have to use Pythagorean theorem at some point
Probably, right?
as the right triangle.
There's a lot of right triangles. What missing information could I possibly fill in so far?
D. Wait.
Z. Go for it. What?
Can you hear me, Miss?
Yeah, I can hear you.
Oh, that's weird. Okay. So we know that AZ is 145, and so is
Good. We also know that this is 145 and that this is 145. Okay. So now, again, how can I find AB and AC?
Wait.
Tyrone suggested Pythagorean theorem. Probably
Yes.
gonna use it at some point. But the question is, what numbers do I put into the Pythagorean theorem?
145 is C. Or
For which triangle? You're correct. So which triangle are you talking about?
ZBD.
ZBD. Okay, for triangle ZBD, the 145 would be the C, that is correct. And what else would I fill in?
A, X, and B, 100.
Good, so x squared, and then 100 squared.
Then you subtract 100.
And what we're looking for is BD. So we're gonna solve and figure out BD. So I'm gonna call this X for now. All right, go for it. See what you get. What do you get for X in this scenario? Perla's got it right. Who else is gonna get it right? Give you guys about 30 more seconds. See if you can get it. Jalen, send it to me privately and I'll tell you if you got it. Good, Emily got it right as well. Okay, let's go through it together so that you guys can see if you got it wrong, like why you got it wrong. So first step, I have to simplify all of my exponents. So what do I get for 100 squared and then for 145 squared?
100 squared is 10,000.
10,000. Watch those zeros.
145 squared is 21,000. Wait. I forget how to say it. So 21,025. I forgot how to say it.
So that would be 21,000 because that's where the comma
25?
is, and 25, yeah.
Okay.
Okay, cool. Now, what do I do to get X by itself?
You subtract
What do I subtract?
10,000.
Good. Minus 10,000. So you got to count those zeros carefully when you put that in your calculator. What do you get?
11,025.
11,025. And then in the final step, what do I do here?
We find the square root.
Good. Take the square root of 11,025. And when you take the square root of 11,025, what do you get? Good, Janelle's 105. All right. So I know X is 105. So this right here is 105. But the question was asking for AB, the whole thing. So what is AB going to measure?
105.
That's BD. I need AB.
Um,
If BD is 105, what is DA going to be?
Also 105.
Also 105. So what's the whole thing? 210. Good, Emily. So that's AB. All right, cool. We're almost there. Now we need to figure out AC, the other side.
It's
AC.
not the same because they're not equal.
Right. They're not the same, but we can use the Pythagorean theorem again.
Yes.
So what can I put into my Pythagorean theorem this time?
Instead of ZBD, you can do ZCF.
CZF, yeah.
And the C would be 145 again.
Mm-hmm.
AX, but this time B is 17.
Good. So x squared plus 17 squared equals 145 squared. If you didn't get the correct answer for the first time around, go ahead and see if you can get the correct answer this time around. Figure out what is the value of x. Couple more minutes, or seconds, I mean. Good job to Janelle's, good job to Emily. Who else can get it right in the chat? All right, 3, 2, and 1. Let's do the exponents. What do I get for my exponents?
What's 17 squared is 289.
Good, 289. And we already know from the previous problem that this is 21,025. All right, so what do I do to both sides?
Subtract
Subtract.
289.
Okay, what's 21,025 minus 289?
Uh, 20,736.
Okay, and then you take the square root. What do you get?
144.
144, nice job. So x equals 144. So I know that line segment FC is 144, so then what's line segment AF?
AF is also 144.
Mm-hmm. So the whole thing, AC,
288.
288. Nice job, guys. All right,
Okay.
last part of this. Is it possible to find BC? Is that possible?
Yes.
What would I need to plug into my Pythagorean theorem?
Um. Hmm. Wait, E is 90.
E is 90 degrees. Mm-hmm.
I'm trying to find BC. Would it C also be 145?
Where?
From CZE?
CZ.
Uh-huh. E.
The line segment is 145, but we're talking about line segments, not angles.
Oh.
Yeah, Perla says you would have to know the measure of ZE. So we would need to know, let's see, what color have I not used yet? I've used almost everything. We would need to know the measure of ZE in order to use the Pythagorean theorem. So in this case, there's not enough information for us to figure out anything else in this whole triangle, because since we don't know ZE, we can't use the Pythagorean theorem. So you need at least one leg to know, one leg, and you need at least two values, basically. So here we had one leg and the hypotenuse for both examples. You could also figure it out if you had both legs, but you were missing the hypotenuse. In any case, you need 2 out of the 3 measures in order to find one left. All right, so like I said, let's see. Like I said, we're also going to do a proof. So here we're going to prove the circumcenter theorem. We're going to do that, and then we're going to do the construction. So after this problem, we will take out our protractors, take out the compass, and work on those constructions. Perla wins. Perla knows that the first one is given. Good, Perla.
How could you? I always do that one.
Okay.
So mean.
Okay, but before we even go through it, let's actually see what this is asking. So given lines L, M, and N are the perpendicular bisectors of AB, BC, and AC, respectively. P is the intersection of L, M, and N. Okay, there's a lot going on. This is a kind of a crazy diagram, okay? So on a test, on a quiz, on anything like this, write it down in your notebook, copy it down. It doesn't have to be perfect, but copy it down so that you can then highlight or use color coding or do whatever you need to do to actually see what's going on. Okay, so I know that line L, okay, so I know a couple of things. I know that lines L, M, and N are the perpendicular bisectors. And that P is the intersection of L, M, and N. How do I know that? Number 2.
It's given. It
Yeah.
says it.
That one's also given. Okay. Then it's saying that PA equals something. So let's think about it. What is going to be equivalent to PA?
Wait, PC?
PC. Yeah. So is it saying PA is equivalent to, and what Tyrone said was PC. And they're saying that the reason for this is that P lies on the perpendicular bisector of AB. So let's look at the reason. The reason tells me a little more. The reason is saying that P lies on the perpendicular bisector of AB. So I'm looking at AB. does that actually, does what Tyrone said is technically correct, but given that this is the reason, is that the conclusion that I can make?
No.
Now, instead of PC, what do you think it is asking for?
PB.
PB, yeah. PB. So not PC, but PB. And that's because perpendicular bisector theorem, so this is technically the perpendicular bisector theorem. What the perpendicular bisector theorem tells you is that when you have a perpendicular bisector, any point on that bisector is equidistant from the endpoints that you cut in half. So we can say this statement thanks to the perpendicular bisector theorem. So this is technically the perpendicular
PB and J.
bisector theorem. Okay, and then look at the reason for the next statement. The reason says P lies on the perpendicular bisector of BC. So what can I fill in if I'm talking about BC?
PB.
PB.
Tell us that.
PB equals PC because it is connected to the perpendicular bisector of BC. Okay. And now we can make this statement that PA
Equal to PB and
equal to
PC.
PB equal to PB and PC. And what is that reason going to be?
CTP. Wait, no. The circumcenter theorem?
That's what we're trying to prove. Again, we're proving the circumcenter theorem, so we can't use it as a reason because it's the reason that we're trying to prove.
Oh, wait. The perpendicular bisector?
We already used that. I'll give you guys a clue. It's going to be, instead of a geometric theorem, the next reason is going to be more of a mathematical rule, an algebraic rule.
I think I know, but I'm not sure. Let me think.
Go ahead and think.
Galen said something.
Equal distant, nope. Okay, again, algebraic rule, not geometric rule. Algebraic rule. What did I do algebraically here?
Yeah.
Think about this, guys. If A equals B and B equals C, I can say that A equals B equals C. What is the mathematic, algebraic reason why I can say that statement? Don't start making up theorems, guys. That annoys me because I never have talked about or taught an ABC theorem. That's not a thing. What allows me to do that? Even if you don't know the name of it, how come I can say that A and B and C are all equal? Jalen, am I talking about congruent triangles here? Okay, since no one remembers it, I'll go over it. Okay, I'm gonna go back to what I wrote up there. A equals B and B equals C. I can basically take this top equation, A equals B, and watch what I'm doing. I'm kind of moving it, and I moved it, so now it's on top of the other one. A equals B equals C. I'm gonna do that again. I had them as two separate things, right? But what variable do they both contain?
B.
They both have a B. So basically, I can take one and lay it on top of the other. I'm transporting the top equation, transporting it, oops,
Wait, it's a theorem?
transporting it down, and now it's on top of the other one. I transported it. This is my transitive
Oh.
property. It's kind of like the substitution property, but a little bit different. It's a transitive property of equality. Okay? Transitive property of equality. Any questions so far? That comes up, that transitive property comes up every once in a while. So transitive property and substitution property, they will come up, and you got to know what they mean. You got to know what they mean. Okay? So any questions? Okay. So like I said, we're going to do the construction now. So go ahead and take out your protractor, your compass, while I set up. We're going to do this twice. We have enough time. We're going to finish on this. We have enough time to do it twice. Let me just get all set up. Move things around here. I have like 50 chords. Okay. All right. So let me label this. So again, let's go back. Let's see who remembers from the beginning. We are making the circumcenter of a triangle. So is this going to be a circumscribed circle or an inscribed circle?
Inscribed?
But I'm making the circumcenter.
Oh, circumscribed.
Yeah, it's the same thing. So this is a circumscribed circle of a triangle. Circumscribed circle of a triangle. So again, is this circle going to be on the outside of the triangle or the inside of the triangle?
Outside.
Outside, good. So I'm going to draw a little bit of like a little example here. But then of course we'll draw an exact example because this is probably not going to be that good. Yeah, that was really bad. Something like this. Wow, that was really bad. Let me do that again. So you would have a
Like
circle.
the circumference. Like the outside.
Yeah. Okay, there we go. So a circumscribed circle. The triangle is inside. Okay, we ready?
Yeah.
Okay. And again, the more you practice this, the better it is. So we're gonna do it once or twice now. When you go home today, you can rewatch the video and practice again and again and again until you memorized how to do this. So I'm gonna start by placing a dot. Actually, no, I'm gonna start by drawing a triangle. So we always start by making the triangle first. And to make the triangle, you can really just put 3 random dots anywhere on your page. They can look exactly like mine, but you could also make them look a little bit different. In fact, try doing it at different places because it's cool to see how it still works. And we're going to connect those dots. All right, so step 1 is simply make a triangle. Make a triangle. Okay, then what we're going to do for step 2 is we're going to find the perpendicular bisector of AC. I'm going to make the perpendicular bisector of AC. So I take my compass. Let me zoom in a little bit so you guys can see exactly what I'm doing. Take my compass. I'm going to set it so that it's wider than halfway between A and C. So it's going to be pretty wide because you want it to be more than halfway. Okay, it's more than halfway. So then I'm going to stick it in A. And yeah?
No.
Okay. So I'm sticking it into A, and then I'm going to draw an arc above
Below.
AC, and then below AC. Okay, so I went above, and then I swiveled it and went below. Then I'm going to do the same thing on the opposite side. I'm going to stick it into C. I'm going to make an arc above.
And keep the size.
Yeah, keep the same size. Thank you, Tyrone. Above and below. I didn't change the width. I kept it exactly the same width. And now I have these 2 cross marks. And what am I going to do with those 2 cross marks?
Draw a line through them.
Draw a line through them. I'm going to connect them. So I've got here and here. All right, so right now what I have here is my perpendicular bisector of AC.
And bisects AC.
It bisects AC, exactly. So A to here is equidistant from here to C. Questions so far?
And it created a right angle.
Created a right angle, exactly. Okay, so that was step 2. Make the perpendicular bisector of AC. Step 3.
Connect them.
Well, yeah, and connect. But that's kind of within step 2 was connect. So I already did that.
Oh.
Step 3 is we're going to make the perpendicular bisector of any of the 2 other sides. So do you guys want me to do it for AB or for BC? Up to you.
AB.
AB? Sounds good. Doesn't matter which one. You can do it for either one. So I'm going to do the same exact thing, but now I'm going to do it to AB. Okay, so I take my protractor. I want it to be wider than halfway, but not too wide either. So this is wider than halfway between A to B. I stick it into A. I go above. I go below. Okay, I go above, I went below. Then I stick it into B. I go above. And I go below. Woo! Oh, almost lost it all. Oh, sorry. Okay. So right now, all I've done so far is go above and below. And now that I have those nice little cross marks, what do I do?
Connect them.
Connect them, exactly. So from here to here, I'm connecting. So here's one and to there. Well, that was a little bit off. I'm trying to be perfect. There we go. Okay. Question so far?
No.
Okay, that's my perpendicular bisector. I'm gonna let you guys catch up if you need to. And I'm also just checking something real quick. Okay. So I actually created a triangle where, and this might happen to you, it might have happened to you this time, but notice those two black lines that I've created, where do they intersect?
In the 3 times.
In the what?
Wait, two.
The two black lines, the two
Oh,
perpendicular
once.
bisector. Yeah,
Like at AC.
right. They connect right on AC. So technically what was supposed to happen is that they would connect somewhere in the middle, but I actually somehow created a triangle that where it's perfectly on AC, and that doesn't usually happen. So guess what? I'm just gonna do this again, which means you guys will get a second chance to either watch or do it with me. I'm gonna do it again because even though that's fine, like technically that's still correct, I do wanna show you what it looks like when it's in the middle. So I'm gonna try again, and I'm gonna make my dots a little bit different. But here's an opportunity for you guys to walk me through it. See how much you already remember.
Make the triangle.
Yeah, make the triangle. Okay, there's my triangle. Now what do I do?
Make a perpendicular bisector.
Of what?
AC.
Of AC. Okay. So of AC. So here's another one more chance to watch how it works. I make this wider than halfway. I'm good. Then I'm going to make my marking above and below. I don't change the width at all. I just flip over to the C, stick it in, go above, and go below. And sometimes look what happened. This might happen to you that they don't connect. That's just because I didn't go long enough when I was at A. So I'm gonna just go back to A and make this a little bit longer until I see where they connect. Same thing up here. I kind of made it a little too short.
It's a T for me.
There
No,
we
it's
go.
not. Sad.
All right, now I can see the intersection points much more easily. So I go and I connect. Okay, then I do the same thing for A, B.
Or any other point.
Or any other point. I could have done it for BC as well. Either way, it works out. So I go to AB. I'm more than halfway. I'll change this a little bit. There's good. I go below. I go above. I go to my B. I go above. And I go below. So there are my two intersecting places, and I connect them.
They intersect again. Well, actually,
Okay.
a little bit more.
Let me make this a little bit darker so we can clearly see that these two lines intersect, and they do so right over here. So I made it inside the circle this time. So I'm good. And what is that circle called again?
The circle, wait.
Yeah.
The circle?
Center.
Okay.
Circumcenter. And as a reminder, these two intersections that I created, they made a right angle here and a right angle there. So those are my perpendicular bisectors. And now that I have my circumcenter, all I need to do is take my protractor.
And make a circle.
And I'm going to make a circle, but be very careful. Remember that my circle has to touch all three vertices. It has to literally, all three vertices have to lie on the circle. So what I'm going to do is I'm going to make my protractor the same width as from the circumcenter
Your
to,
protractor.
or my compass. I'm going to make it the same width from the vertex, one of the vertices to the circumcenter. So notice from A to the circumcenter, and I match it up and look at what happens. It's the same thing from B to the circumcenter. See that?
You always want to check if they're all the same way, so else it won't be even.
Right, and it's the same thing from C to the circumcenter. Notice, I didn't change anything. It's all the same. So what you can do now that I have it at that width, I stick my protractor into the circumcenter, and let me clear some space because now I'm going to do the magic step. Let me move this all around. Hold on. Okay. I stick my protractor into the circumcenter. And I'm just going to go. It's better to rotate the page. So just hold your protractor steady and, oh my goodness, okay. And rotate the paper. And there is my circumcircle, my circumscribed circle. Let me rewrite all the steps. So step 1 was make a triangle. Step 2 was make the perpendicular bisector of what?
Wait. AC.
Of AC. That was the first one. Then I made the perpendicular bisector of
AB. Wait. Yeah, AB.
Yeah, AB. And I could have done BC, but no matter what, it still works.
It will always make a circle.
Yeah, so you're gonna make two perpendicular bisectors. You can choose which two of these three sides you use for them, but as long as you make it twice, you're good. What was step 4? Once I made those two perpendicular bisectors, what did I do?
You make a circumcenter.
So label the circumcenter.
Then you make a circle that passes through all three vertices.
Good. So the important thing is to set the compass to the width of, in this case, we did the width, here, let me fix that. The width from any vertex, so vertex to the circumcenter. So I tested it to make sure that the circumcenter was equidistant from A, B, and C. And once I tested just to make sure, then you can create your circle.
Yay. Circle boy.
And again, this is the circumscribed circle of
Inside a triangle.
a triangle. Circumscribed circle of a triangle. How do we do? Did we keep up?
Yes.
How did people do? Give me a thumbs up if you were able to keep up and do it on your own as well. Yeah, Tyrone, you didn't have you didn't have a compass. But how about everyone else? Jalen, give me a thumbs up. Anyone else? Tyrone, I know. Okay, well, good, because here's your homework.
Make 10,000 circumcised circles.
Homework. I'm writing it down here, old school style. Homework. Make a circumscribed circle. Oops. Circumscribed circle on a sheet of paper.
Send it to you through my.
Yep. And send me a pic. This is due by Wednesday at midnight.
I have to hurry and get a compass.
So if you don't have your compass, if you don't have a protractor, yeah.
My mom said yes, but like she didn't like answer the email, but she said yes. I keep telling her, but she never like responds. So
Okay, good. I was gonna ask you about that. She should have gotten a separate email today with the form that she can sign.
Oh no!
Okay, I'll tell her.
The voice thing.
Oh no, the echoes. All right,
I forgot
so
to do the thing you sent me. I'm sorry.
it's okay. Perla did it, and that's why we had that conversation. Okay, so this is a homework. Again, you can watch this video, which I will post as soon as class is over. Watch this video again, or you can use any other video on, if you Google it, you can find like 10 videos, okay? Circumscribed circle, you can find it. And then it's due on Wednesday night for a homework grade. Any final questions? All right. You'll probably do it a couple of times because, you know, I messed up the first time around and then I had to do it again and then I was able to do it. So it might take you a couple of tries, but, you know, that's even better because that's more practice for you. All right. So let me go ahead and X out of this. All right. Everybody have a good night. I won't see you tomorrow, but I will see you on Wednesday. So have a good break. Enjoy it. And I'll see you back
Before I leave, I have to say something.
Yes, Tyrone.
I rewatched the video